Hello guys, welcome back to my channel. This is G Varun, pursuing my education in Sri Venkateshwara College of Engineering, Bangalore. Today in this video, we will discuss about vector calculus. Now, let us dive into the topic. First, introduction to vector calculus. Vector calculus is a branch of mathematics that deals with vector fields and the differentiation and integration of vector functions. It provides a powerful framework for understanding and analyzing physical phenomena in fields such as physics, engineering, and computer science. Vector calculus extends the concept of calculus to higher dimensions, allowing us to describe and solve problems involving vectors. Vectors in three-dimensional space. Vectors are quantities that have both magnitude and direction. In three-dimensional space, vectors are represented by arrows, with the length of the arrow representing the magnitude and the direction of the arrow representing the direction. Vectors can be added, subtracted, multiplied by scalars and have properties such as dot product and cross product. Vector fields. A vector field is a function that assigns a vector to each point in a given region of space. Vector fields can represent physical quantities such as velocity, force, or electric fields. The behavior of vector fields can be visualized using vector lines or vector plots. Differentiation of vector functions. The differentiative of vector function describes how the vector changes as the input variable changes. The derivative of vector function is itself a vector function, where each component is the derivative of the corresponding component of the original vector. Differentiation of vector function involves taking partial derivatives with each of the following variables. Next, gradient of scalar field. The gradient of scalar field is a vector field that points in the direction of the steepest increase of the scalar field. The magnitude of gradient represents the rate of change of the scalar field. The gradient is orthogonal to level curves or surfaces of scalar field. Vector review. Gradient of scalar view is represented by the following diagram. Next, divergence of vector field. The divergence of vector field measures the rate at which the vector field flows outward from each point. It is a scalar quantity that represents the net outward flux of the vector field per unit volume. Divergence is used to analyze the behavior of vector field in terms of source and sinks. Next, curl of the vector field. The curl of the vector field measures the rotation or circulation of vector field around a given point. It is a vector quantity that is perpendicular to the plane of rotation and points in the direction of an axis of rotation. Curl is used to analyze the behavior of vector field in terms of rotational effect. Next, we will discuss about line integrals. Line integrals are used to calculate the total contribution of a vector field along a curve or path. They can be interpreted as the work done or the accumulation of the quantity along the curve. Line integrals involve integrating the dot product of the vector field and the tangent vector to the curve. Green's theorem. Green's theorem relates a line integral around a simple closed curve to a double integral over the region enclosed by the curve. It is a fundamental theorem in vector calculus and has applications in fluid mechanics, electromagnetism, and other areas. Green's theorem can be used to calculate flux, circulation, and other physical quantities. Surface integrals. Surface integrals are used to calculate the total contribution of a vector field through a surface. They can be interpreted as the flow of flux of a vector field across the surface. Surface integrals involves integrating the dot product of the vector field and the normal vector to the surface. Next, divergence theorem, which is also known as Gauss theorem. The divergence theorem relates a surface integral of a vector field to a triple integral over the volume enclosed by the surface. It is a powerful tool for calculating flux and volume integrals. The divergence theorem is widely used in physics and engineering, such as in fluid dynamics and electromagnetism. Next, we will discuss about Stokes' theorem. Stokes' theorem relates a surface integral of the curl of a vector field to the line integral around the boundary of the surface. It is a fundamental theorem in vector calculus and has applications in electromagnetism and fluid mechanics. Stokes' theorem provides a connection between line integrals and surface integrals. Next, we will discuss about applications of vector calculus in physics. Vector calculus is extensively used in physics to describe and analyze physical phenomena. It is used in fields such as electromagnetism, fluid dynamics, quantum mechanics, and general relativity. Applications include calculating electric and magnetic fields, fluid flow, wave propagation, and gravitational effect. Applications of vector calculus in computer science. Vector calculus is also applied in computer science and computer graphics. It is used in areas such as computer vision, image processing, 3D modeling, and simulation. Applications include image recognition, computer animation, virtual reality, and machine learning algorithms. Next, vector calculus softwares and tools. There are various softwares and tools available for performing vector calculus calculations, and visualization. Popular software includes MATLAB, Mathematica, Maple, and Python libraries such as NumPy and SciPy. These tools provide the functionalities for numerical computation, symbolic calculation, and visualization of vector fields. Finally, the conclusion is vector calculus provides a powerful mathematical framework for understanding and analysis vector fields. It extends the concept of calculus to higher dimensions, allowing us to describe and solve problems involving vectors. Vector calculus has a wide range in applications in physics, engineering, computer science, and other fields. Thank you for watching my video. Please do like, subscribe to my channel. Thank you all.